Continuous random variables are denoted with PDF, standing for probability density function, as opposed to our probability mass functions that were for discrete distributions. Since it is a function, we'll use f of x to illustrate that we're dealing with a continuous random variable as opposed to a discrete one. Now we're going to have some form of line or slope or something along those lines, and the area underneath that curve over the x-axis must equal 1. We're going to use it very much like the probabilities, where we summed all the probabilities up and they must equal 1. This is the same sort of thing. Now, things that would be considered continuous random variables are anything dealing with, say, time, speed, volume, that sort of thing. Things that can be in flux, volume of a glass of water or whatnot. Now, say you're looking at time which is a continuous variable. If you decided to round the time to the nearest second or minute or something along those lines, you could create a discrete distribution. Time itself is continuous. Now, an easy distribution to look at and solve for is the uniform random variable. It's continuous, and a uniform random variable, using the word uniform, means the same for all factors. So we're going to get a straight line out of this. So the function is going to equal just a flat line. You're going to have f of x equaling one value. So it's going to equal that same value in between 2 points. The larger value will be the letter D, the smaller value is C, and there'll be numbers, and you'll be able to calculate that. Now, the mean is pretty intuitive. If you're dealing with just a straight line and you want to find the mean of that distribution, it's going to be the average of the 2 points, the larger point and the smaller point, the very middle of it. So we add the 2 points up and divide by 2, taking a typical mean. The variance is less intuitive, and this is the formula for it. So the variance is equal to the larger value D minus the smaller value squared, and then divided by 12. And the standard deviation is just the square root of that. And this is our formula for that. Now, if we're looking for the probability that x is between any two values, provided that these values are also within D and C, we calculate the difference in those values and divide by D minus C, which is our function, or in essence we're multiplying by the 1 over D minus C. I have an example set up. Also, I'd like to note that the equal to signs aren't involved. If you want to put the equal to signs, that's fine, but as I'll show you in a minute, the probabilities that x is exactly any value is 0. Alright, so this is a uniform distribution. C is the value of 20 and D is the value of 45. So we're getting a straight line function between the numbers 20 and 45. 45 minus 20 is 25, so our function of x is the straight line of y equals 1 over 25, or f of x is 1 over 25. This means that the area underneath this curve is 1, and we can see that very easily. So the area of a rectangle is base times height. Now, the distance of the base is the distance between 20 and 45, and that is equal to 25. And the height is this 1 over 25. So that area equals 1. So the area underneath our curve is 1. So there is no data here, no possible values to be there, and none over here, and certainly none negative, and so forth. Now you could make a uniform distribution that goes negative, but I'm looking at the first quadrant only, and you can move stuff over there, and this is the null set area over here. Now, the probability that x is greater than or equal to 30 is equivalent to the probability that x is between 30 and 45, and 30 is in this general area here. So we look for the distance between 30 and 45, and that is going to be 45 minus 30. And that's going to be over this 25, over the d minus c, which is 25. And that equals 15 over 25, or 0.6. Now, this is the exact same question. That also equals 0.6. The reason is because of the probability that x equals 30 is the distance from 30 to 30, which is 0, and that's over 25, but 0 over any value is going to be 0. So these two things are equivalent, and anytime you're dealing with a continuous distribution, the equal to sign is irrelevant.